This question is from Pure Book 1, Exercise 5G, question 10. So we are given two lines and we have to find out where they intersect the x-axis and then when they intersect with each other, and then find the area of the triangle formed by those 3 points. So for the first two parts, we just have to substitute in to the equations they've already given us. There is a small gotcha there, remember, because it's crossing the x-axis, that means that it's y that must be 0. So we substitute in, we find that x must be 2.5 for the first one, for part A. And remember to say where it intersects, so we need to write down the actual coordinates of the point. And then we do the same for part B. For part C, they want us to find out where the two lines cross. So I've rearranged the two lines into this form, and we know that x must be the same as x for L1 and L2, and y as y. And so now I've got 4x is equal to 5y plus 10, and 4x is equal to 2y minus 20. And so now I can simply say that means that 5y plus 10 must be equal to 2y minus 20, which of course means that y must be minus 10. And now just substitute that value for y back into one of those two equations. I'm putting it into 2, and so then I find that, and I solve that to find that x must be negative 10. I can then write down the coordinates of the point at which they cross. I use the equation for line 2 for calculating that. So I'm just going to double check by substituting those values into the equation for line 1. And I'm going to go all the way back to the original equation given to me in the question, because that way then I know that one at least is going to be correct. Great, so that did work. So that means that I'm probably correct so far. Part D is asking to find the area of the triangle formed by A, B, and C. And as you can see, I've drawn a diagram for that. I didn't draw a diagram for the lines because essentially that's one which you can solve using simple algebra, and drawing the actual lines doesn't really give you any more information. However, here you're looking at a geometric shape, and it's much more important then that you get a feel for what it actually will look like, because of course when we're calculating the area of that, we're going to be using base times height over 2. And so we need to know where our base is going to be and what we mean by the height. And now we can simply calculate. Notice I have put how I'm going to calculate it. That'll be a method mark, and then I've just written down the calculation. I put in brackets units squared. It's good practice to do it, but it won't actually lose your mark if you don't put that down.